is also available on SlideShare. The link given here will help you find the presentation. The aim of this video is to show some solved example for ellipse drawing algorithm which may not be available in regular textbooks. This is the algorithm for ellipse drawing. This algorithm can be found in any standard computer graphics textbook. I have taken reference from Hearn and Baker. You can see the link to this textbook in the last slide of the presentation. Now let us go through the algorithm and solve an example to find the pixel positions of any given ellipse in both regions, region 1 and region 2. Looking at the algorithm here, it is very clear from the algorithm that there are two paths to this algorithm, region 1 and region 2. First and foremost, for any ellipse to be drawn, the given or input or the known should be the two radiuses of the ellipse, Rx and Ry. I have mentioned in the circle drawing algorithm that we find the pixel positions of only the octant or 1/8 of a circle, because all the other 7 parts of the circle will be mirror images. Whereas here in the ellipse drawing algorithm, we have to find the pixel positions for one quadrant, the first quadrant. X is positive and Y is positive for the first quadrant. The ellipse is a mirror image for the other 3 quadrants. But even in the first quadrant, on the y-axis, we have the Ry or radius on the y-axis, and the x-axis we have Rx, which is radius of the x-axis. Hence, starting from the y-axis, x equal to 0 and Ry, we go on till this condition. This is region 1. When we reach this condition, then we will move on to region 2 and we use these equations to calculate from more or less x equal to y position, or 2ry square x when it is greater than or equal to 2rx square y. When we reach this position, then we follow this till we reach the Rx comma 0, that is Rx x-axis coordinate. Let's look at the example. I have written the algorithm on the left hand side and we have solved the problem on the right hand side, so it becomes easy for you to compare parallelly the algorithm as we solve the ellipse drawing algorithm. The example here, you can see Rx is 10 and Ry is 5. The y-axis is 5 and the x-axis is 10. So x0, y0, the first point to be plotted is always on the y-axis. So x is 0 and Ry is considered. So 0, 5 is the first point that we plot on the y-axis, which is part of the ellipse. This is the first one. For ease of calculation, we will calculate Rx square, Ry square, that is 10 square and 5 square, and also 2Rx square and 2Ry square, that is 2 times 100 and 2 times 25, 250. This is the equation to find the first decision parameter. This is for region 1. I have mentioned here, this is for region 1. So substitute Ry square, Rx square into Ry plus 1/4 of Rx square. All the variables that you can see here, the values are available here. Rx square, Ry square, 2Rx square and 2Ry square. Now once we have calculated the decision parameter, we will check whether the decision parameter is less than 0. If it is less than 0, then x will be plus 1, yk will be constant, and the next decision parameter is calculated with this equation. Otherwise, x will be incremented, and as you can see here, yk minus 1, y will be decremented. So this is giving us minus 450, which is less than 0. Therefore, x increment, y constant. So 1, 5. 0 is incremented, y is constant. This is the if case. And with the help of this equation, by substituting into this equation the new decision parameter equal to old decision parameter. Old decision parameter is minus 450. plus these values are available here. You get the new decision parameter. So we continue like this. The new decision parameter, again check whether it is less than 0 or greater than 0. And you can see here that this is less than 0. Therefore, x is incremented, y is constant. And the new decision parameter is minus 250. Minus 250, again less than 0. So 2 became 3 and 5 is constant. So we go on like this. So you can see here I have mentioned whether we are going into the if case or the else condition. After this, when we reach here, there is a condition where the decision parameter is 150, which is greater than 0. Therefore, it is the else part where xk plus 1, yk minus 1. So 4 became x plus 1, xk plus 1, 4 became 5, but y became k minus 1, 5 minus 1, 4. This is the difference in the else case, and the next decision parameter is calculated using this equation, which is giving us minus 375, which is again less than 0, therefore the if case, and we continue like this for if case. Again there is an if case, 325, this takes us to the else part, so this is the else case. We have reached 9, 2, where our 2ry square xk plus 1 is greater than 2rx square yk plus 1. When this is greater than this, or 9x is greater than y here also, this is not the condition to be checked. The condition to be checked is 2ry square xk plus 1 when it is greater than 2rx square yk plus 1. We stop. Then we move on to the region 2. What is important to note here is the last point of region 1 that we have calculated before the condition is reached, that is 9, 2, will be the first point here. So we start with a fresh x, y, which is equal to 9, 2. This 9, 2 is nothing but the last value of region 1. Here also, this is the decision parameter for region 2, that is why the 2 here, P2 dot naught. This is the formula. When you apply the formula, the number I obtained is minus 143.75. We will check whether it is greater than 0 or less than 0. If it is greater than 0, this is the condition, else this is the condition. Here it is not greater than 0, so it is else xk plus 1 and y is decremented. So we are in the else part, x is incremented, 9 became 10 and 2 became 1, 2 minus 1. This is the condition. It is easy for you to locate because I have written here which case that we are following. And the new decision parameter equal to old decision parameter, that is minus 143.75 plus these values which can be calculated. Now it is 131.25. Is it greater than 0? Yes. So it is the if condition. If it is if condition, xk, yk minus 1. X is constant, y is minus 1. 1 minus 1, 0. We stop here because we have reached rx, 0. You can see here rx is 10 and 10, 0. 0 because we are on the x-axis, y is 0. So this is our last point. These are the pixels that we calculated from here up to here, region 1. This is region 2. This algorithm can be found in this link. This is the Hearn and Baker e-textbook link. You can refer this link for the algorithm.